All right, let's just jump right in. There's one single experiment in all of physics that is so strange, so completely against all common sense, that it basically breaks our entire view of reality. It's called the Double Slit Experiment, and what it shows us is a secret about the very fabric of the universe, a secret we're still trying to figure out today.
And hey, don't just take my word for it. The legendary physicist Richard Feynman himself said this one experiment contains the only real mystery of quantum mechanics. He was convinced that if you could just, wrap your head around what's happening here, you'd understand the wild, beautiful, beating heart of the quantum world. So yeah, let's give it a shot, shall we?
So our story kicks off with a really simple question that started a scientific war that went on for 200 years. What is light? Is it a stream of tiny individual particles, or is it something more like a continuous flowing wave?
In one corner, you had Sir Isaac Newton. He argued light was made of these tiny little projectiles he called corpuscles, basically like microscopic bullets flying in perfectly straight lines. But in the other corner, you had thinkers like Thomas Young, who thought, no, light is a wave, and it should ripple and interfere with itself, just like the waves you see in a pond. For a very long time, this was a huge debate.
So, how do you settle a fight like that? Well, you run an experiment. Imagine you're firing, say, paintballs through a wall with two vertical slits in it. What would you expect to see on the wall behind it? It's pretty obvious, right? You'd get two solid lines of paint right behind each slit. That's the particle prediction. Easy enough.
But when Thomas Young actually did this experiment with light back in 1801, that is not what he saw. Not even close. Instead of two simple bands, he saw this bizarre series of alternating bright and dark stripes. This is called an interference pattern, and it's something only waves can do. Where two wave crests meet, they reinforce each other, making a bright band. Where a crest meets a trough, they cancel out, making a dark band. So, case closed, right? Light is a wave. And for about a century, that was the final answer.
But then, the 20th century rolls around, and we get this amazing new technology that lets us do the experiment in a whole new way, a way that would turn physics completely upside down. We can now fire individual bits of matter, like electrons, one single particle at a time.
And this leads us to the absolute core of the mystery. If we shoot electrons, which are definitely tiny little particles, one at a time, there's no way they can interfere with each other. There's nothing for them to bounce off of. So we should finally see those two simple bands that Newton predicted, right? I mean, it just has to be.
So let's run it. We fire the first electron. It zips through the slits and thwack! One dot appears on the screen behind. We fire the next one. Thwack! Another dot somewhere else. At first, it just looks totally random, just a few scattered hits here and there.
But we keep going, firing one electron, then the next, then the next. And as we watch, something impossible starts to happen. Those random dots, they aren't random at all. They're starting to cluster in very specific places, while avoiding other places completely. A pattern is definitely emerging from the chaos. And after thousands and thousands of these individual electron impacts, you see this. The first giant shock. The electrons have formed a perfect wave interference pattern. I mean, just let that sink in for a second. Each particle was sent alone, yet it somehow knew to land in just the right spot to help build a pattern that only waves should be able to make. The conclusion is just inescapable. The single electron went through the slits and somehow interfered with itself. This forced physicists to accept a mind-bending new reality called wave-particle duality. It means that electrons, photons, you, me, everything aren't just particles or waves. They're somehow impossibly both at the exact same time. So how does one little particle interfere with itself? The only way that could happen is if it went through both slits at the same time. This is the idea of superposition. Before you measure it, the electron isn't a solid little point. It's more like a wave of pure potential, a cloud of possibilities that exists in all possible states at once. It goes through the left slit, it goes through the right slit, it does both, and it does neither all at the same time.
Okay, but the rabbit hole gets so much deeper. Physicists, totally stumped by this, decided, all right, we have to know for sure which slit does the electron actually go through. So they set up a detector to find out. And what they discovered next is chilling. It's almost as if the universe itself knows when you're looking at it.
So, quick recap. When we just let the experiment run and we don't look, the electron acts like a wave, going through both slits and making this beautiful, complex interference pattern. This is the universe just being itself when no one's around.
Okay, now for the change. We put a tiny little detector right by the slits. Its only job is to record which path the electron took.
It doesn't block it, it doesn't touch it, it just gathers one tiny piece of information. Was that the left slit or the right slit? That's it.
And the instant we do that, the whole thing collapses. The wave pattern completely vanishes, and instead, we get two simple bands. Exactly like we expected with the paintballs at the very beginning. The simple act of measuring which path the electron took forced it to pick a path, and by forcing it to act like a particle, its wave nature was completely destroyed.
This is what physicists mean when they say the observer collapsed the wave function. The universe, it seems, will only show you its ghostly wave of possibilities when you're not trying to nail it down. The second you ask, "Hey, where are you?" it gives you a definite answer, and all the other possibilities just, poof, vanish. The act of knowing changed the physical reality of what happened.
And if you think that's as weird as it gets, oh, just you wait. Scientists decided to push this idea to its absolute, most illogical, mind-breaking conclusion. It's an experiment called the delayed choice quantum eraser.
Now, this is where our sense of time just completely falls apart, so follow this really carefully. A particle goes through the slits. We record which path it took, so it hits the screen and helps build a simple two-bond particle pattern. Okay? That event is over. It's in the past. But we send that which path information on a really long detour. Sometime later, after the particle has already landed, an experimenter gets to make a choice. They can either look at that information or they can erase it without ever seeing it. And here's the insane part. If they choose to erase the information, the pattern on the screen, a pattern which had already formed, retroactively changes into a wave pattern.
This just leaves us with this deeply unsettling question that's almost impossible to answer. Did a choice we made in the future just reach back in time and change what a particle did in the past? I mean, the implications for cause and effect, for the very idea that time only flows in one direction, they're just staggering.
So, what on earth is going on? What is reality actually made of? As you can imagine, these results kicked off a century-long brawl over the very nature of existence, with some pretty wild ideas being thrown around.
The most common explanation, the Copenhagen interpretation, basically says reality is just a set of probabilities until we look, and we shouldn't even ask what it was doing before we measured it. Then you have the many worlds idea, which says the wave never collapses at all. Instead, every single possibility happens, each one branching off into its own parallel universe. And other ideas, like de Broglie-Bohm, suggest particles are always real, solid things, but they're being guided by a hidden, invisible pilot wave. None of these sound like common sense, because, well, the quantum world clearly isn't.
All of this has led a lot of modern physicists to an even stranger conclusion. Maybe information is the most fundamental thing in the universe. More fundamental than matter, more fundamental than energy. Think about it. The universe doesn't seem to care if the particle actually went left or right. It only seems to care if the information about which path it took exists somewhere. If that information is out there, it's a particle. If it's not, it's a wave.
So the biggest takeaway from all of this is that reality isn't some fixed, static thing that we just passively observe. The double slit experiment shows us that we live in a participatory universe. It doesn't just show us its secrets. It seems to wait for us, for an observer, to ask a question. And the very nature of the question we ask seems to determine the nature of the reality that gets created. Which leaves us with one final profound thought.